Hello, and welcome back to Every Problem. This is Stewart Calculus 8th edition, section 1.1, problem number 47. For problems 45 through 50, the instructions are to sketch the graph of the function. And here at 47, we have g of t equals the absolute value of 1 minus 3t. So with most graphs, if it's not something that we can see instantly, it's probably good to make a table of values for it. So let's go ahead and get started, and we'll have x and y, and let's just make some arbitrary values. So we'll do -2, -1, 0, 1, and 2. It's usually a good starting point for finding some points of a function. So if we plug in -2, we'll get 1 minus 3 times -2, which will end up giving us 7, because that'll be 1 minus a -6, which is 7. If we plug in a -1, well, that'll just get us, looks like it'll give us 4. Plugging in 0 gets us 1. Plugging in 1 will get us 2, and the reason for that is because we have 1 minus 3 times 1. That gives us 1 minus 3, which is -2, but remember we have the absolute value of -2, so that will get us +2. Then when we plug in 2, that's 1 minus 3 times 2, which ends up being 1 minus 6, -5, and absolute value of -5, which in turn gives us +5. Now, there is one key thing missing from this. So we have our table of values, and let's just sketch this out really quick. So we have this function. Let's see, let me make this a little bit bigger so it's easier to see. So we have this function where -2 gets us 1, 2, 3, 4, 5, 6, 7. So -2, 7. -1, 4. Let me erase this tiny dot here, that way there's no, there we go. Okay. Then at 0, we have 1. At 1, we have 2. So then at 2, we go all the way up to 5. So there's something like this, but it doesn't quite make sense, because with this function we shouldn't have the slope changing twice there, right? Because that has a slope of 1, and then here we have a slope of 3. It doesn't really make sense for it to change, for the slope there to change twice on us, because we don't have any quadratics or anything. We just have this 3t here, and so that's something to take note of. Now, with that said, anytime we're sketching a graph, it's always good to find the x and y. Here, I'll try that again. It's always good to find the x and y intercepts. And the reason for that is because those can sometimes be crucial points to where the graph might bounce or curve or do something special, and sometimes they just help you make better sense of the information that you're given. So with the y-intercept, we did plug in 0 for x, and we ended up getting 1. But what about the y-intercept? So we'll have to ask ourselves, what makes y equal to 0? Well, we'll have, our function was the absolute value of 1 minus 3t, right? But of course, absolute value of 0 is just 0 anyways, so we can drop the absolute value signs, and we can just say 1 minus 3t equals 0. So doing some algebra, we'll add 3t over to both sides. Oops, there we go. Then we can have 1 equals 3t. Divide both sides by 3, and there we have t equals 1/3. So at 1/3, right in here, I'll have to zoom in to kind of fit the spot in. So at 1/3, we happen to have y equals 0. And that's going to be the missing piece of information. So we'll zoom in, and we'll find the point 1/3 roughly right here. And I'll draw this in yellow because it'll be right on the axis. And so that's going to help connect the line. And now that will make sense. And so when we zoom out, you see, oh, okay, there we go. Now it has the same slope all the way through. And that's going to be the sketch of our graph.